Okay. Uh, can you see the screen now? Okay. Okay, so this is the user interface of Midas Gen, and we'll start with the grids that you can form using Structure tab. In that, we can go to UCS or plan in which grids are there. We can define point grids as well as define line grid structure. So in this, we can add. So basically, adding nodes and creating elements can be done on a particular grid given by us. So let's call this grid as typical. Over here, the option of giving that spacing is in particular, like you want to give starting from 0, you want to give a -5 like it has been shown, then 2, then 3, then you want to give multiple. So if in that case you can say 3 numbers at 4 meter. So that can be done. So this is X. Let's add the Y grid lines. Let's say I have 5 and 3 at 4 meters. So we make one line grid and then we can just simply apply. Okay, so here we can see right now grids that have been formed. Now we'll go to node elements and create nodes. So this is how you can create nodes where you can give the coordinates. Okay, so these coordinates, now already a grid has been formed. So there will be a snapping option you can see over here at the right corner. Snapping options are there. So right now line grid snap has been turned on. So with that you can just click on the points where you want the nodes to be created. In this way nodes can be created. Distances also can be given. Then you can copy or move any of the nodes with this translate command. Translate command is the one that is there for copying or moving. It is there in nodes as well as in creating elements. So you can do it with equal distances or unequal distances. You have both the options. So let's say we have copied all the nodes created with the distance of, let's snap on the line grid of 2 meters and apply. So now you can see over here nodes have been copied. Next there is divide option in which number of nodes can be divided. Then merge options when entire structure is created, or maybe you have faultily imported any CAD file in which certain nodes have been created. So all those nodes at certain tolerance will be merged with using this command. Delete option is there for nodes in which you can delete the free nodes that have been generated, any free nodes. Similarly, you can rotate the nodes, project the nodes. Projecting nodes is like you have an element created and you want to project certain nodes on that created element, beam element or any element. Then there is mirror option. Basically, there is planes defined over here. So you can copy or move using this option, mirror option. Then there is scaling. So you can change the scale factors of the nodes that have been created. And we have got node numbering. So in case of numbering the nodes, like why do we require to number the nodes correctly? So when it comes to columns that we require to design or the foundations that we require to design, so in that case, we need the columns to be numbered properly. So by doing the node numbering, you can get your columns or the foundations numbered with the order that you would like to set by default. So you can get the node numbers by the display option. Over here we have certain buttons for the node display option. So you can display the node numbers here. So as you can see, the nodes have been numbered just the way I had made them, created them. So you can change it with the first, let's say plus X, and I select all and apply. Wait. Yeah, select all and apply. So that is how the order you can change, and you can have different numbering. So also you can start with different numbers also, just to identify that level or to identify that column. So manual or automatic renumbering can be done. Also, just like you have in other softwares or maybe through Excel, you can just import or copy paste the entire model or the entire plan using this table option. So if you delete certain nodes over here, it will be reflected over here. The three nodes have been deleted. So you can create also or the nodes and elements using the table format. So this is one way of doing the nodes. Next, we'll create elements. So in elements, we have got options of truss, in which all the actual forces will be considered or actual stresses will be considered. Then tension only, hook or cables are tension only members. Then compression only, that is a gap. Then general beam or tapered beams are the ones that we will be generally using. The beams, the normal ones. Then plates, for creating any slabs, you can create plates. Then plane stress, plane strain elements, axis symmetric elements, or solid elements are other types of elements. Then wall element is also there that we require to use if we want to create shear walls and design them. So it is very important when it comes to shear walls and slabs, because if you create a plate as a shear wall, then you would not get a design. Okay, so while creating any element, you will always get materials and section properties at the time of assigning or at the time of creating them itself. So you do not have to like go to properties tab and do everything. Instead, you can just directly go to this dot dot button at the start at the side of this name, and you can get to that option of assigning properties or defining properties. You can add or you can import them. So let's add certain concrete material. So you can see over here that there is a huge database of concrete materials. Also, there is a database for steel materials. This is all according to IS 456. You can get it into other codes as well. BS codes, ACI codes, ASTM, Euro codes, all codes are available. So let's create a concrete material. Let's create a beam and a column. So there is a huge database for defining sections also. When it comes to steel sections, when it comes to concrete sections, when it comes to steel reinforced concrete sections, we have got combined sections in which you can analyze and design as well. And there are composite sections as well, or you can define your own section at the value. So let's define a solid rectangular beam. Let's name it as beam. So when it comes to steel material, there is a database again, but over here when it comes to rectangular, we'll put it as a user base, 0.3 by 0.3. We can say apply. Let's create a circular column as well. Solid round. Let's take it 0.3 only. Okay. Now defining thickness, because I'll be showing you how to create wall elements and plate elements as well. So add. In this, the bending is taken in plane and out of plane, or you can have different, you can define different thicknesses for in plane or out of plane bending. So let's take it in plane and out of plane the same thickness. Let's take 0.2 for wall. Let's take 0.15 for slab. Okay, so now we have created, defined beams and columns. Now let's see how to create them. To create the beams, you have to click on the nodal connectivity, which is given over here. And then you have to click on these nodes. So as you can see over here, that the elements that I have created, you can view it directly in 3D. So this is one way. Also, you can see wireframe structure. To go to that, over here, there is an option, a button, hidden button, or you can just press Ctrl H. And now you can view just the line elements. So this is the line element. And again, you click on it, you can see the 3D element again. There are options over here to intersect nodes and elements as well. So if you create some more beams, and now over here there is another option. Let's go to the top view. This is the view option. Over here we can see isometric, front view, back view, right view, left view, top view. So we'll go to the top view. Okay, so in the top view, I'll show you that the snapping option for center of any beam can also be taken. Okay, there is also option for orthogonal. So only the beams will go in that orthogonal direction only. It won't go in any other direction unless and until it has been defined. Okay, so this is how you can create beams. Let's see how to go ahead with the other options. We have got line elements on curve, that is we can create curved beams. So in this also we have got element type options, like you can create curved truss or curved beam itself. Then there is options of arcs by 3 points or by center and 2 points. Then circle by 3 points, circle, ellipse, parabolic, cubic by 4 points. So all these options are available to create curved beams. So again we select the material property, the beam property, then the beta angle, as in the angle at which your section is to be rotated. Okay, and the number of segments over here, in how many segments you can divide your curved section, so that we can see. We can change it. Let's take it 10 or something. So we can just select certain points, nodes or grid points, and you can see over here a curved beam has been created. That is option for the create line elements on curve. Okay, then let's create some plate elements. Again the nodal connectivity by plate elements over here, you need to change that. Again there are types, 3 noded or 4 noded. Then there is type thick or thin with the drilling DOF, that is degree of freedom. Then the thickness you can select for plates. Again click on the nodal connectivity and you can create your plate elements. So now your plate elements have been created. Now let us go ahead with this translate option, in which copy and move can be done like we have seen before. Another option is extrude. Now extrude is a very interesting option. In extruding, you can extrude the node element, like convert this node element into a line element, or you can have line element into planar element, and you can make a planar element to a solid element as well. So let's now make a wall. So you select the element type, choose your thickness, and define the height of the wall. Let's take 3 meters, or let's take it as minus 3 meters to make it go down. We'll select one beam and we'll apply. So now we can see over here that the beam has been converted to a wall element. Okay, then there are other options to divide elements. So we can divide any particular element into 2 parts. Also we can merge those 2 parts if created. Then we can intersect certain, in case it happens, some errors happen because of importing options and all. The elements are closely located to each other, the nodes are closely located to each other. In that case errors might come, so you can obviously use this intersect elements option or merge element option. Then other is the delete option. You can rotate, you can mirror it. Also you can change the number of the elements. So in case you change the element numbers you can display them at the side of the node's display number. So this is how you can see the element numbers. So maybe at every floor level you can change the the starting number. Maybe say you want to say 101, then 201, 301, like that. At different floor levels you can define different uh, element numbers. Next is I'll show how to change the parameters. So if you have made the entire model and now you want to change certain parameters, so you can change material ID, like you can change the material from here. You can create a new material and change it by selecting and assigning. You can change the section, change the thickness, change the wall ID also. So it's like you have made certain number of walls in the entire frame and you have not given any wall ID as such. So there is auto option and there is fixed number also. So you can give in auto option, it will identify the walls in one plane and it will give different wall IDs to different walls located at different locations. Then there is element local axis that also you can change. You can display the element local axis with this display option at the bottom. So there is element over here. You can display the local axis or you can display the local direction also. So in what way the element has been defined or has been created, and you can change accordingly. You can change it by reference point, you can change it by a certain direction, that is reference vector, or you can have an increment. Similarly, element type can also be changed. Now if you have created certain truss members and you want them to be only for tension or compression, or you want to change it altogether into a normal beam section, so that can be done. Or you want to change any wall that has been created by using plates, so you can change it from plate to wall. Again in wall there is membrane and plate. So in membrane the forces will be in plane, and plate it will be in plane and out of plane also. Then reverse element local, so whatever local directions have been there for that element, it can be reversed, like it will be absolutely opposite. Align element local, if there is certain element and I want to align the local axis, the local direction of this element to other elements, that can be done over here at align local element local. That is done. So these are the change parameter types. Also, just like we saw for nodes table, there is elements table also. So you can change anywhere your beams. You can change the type over here, subtypes. You can change the material IDs, property IDs, the angles, which nodes it should connect. You can see over here. And the rest options, so you can have these limits to be taken or not. So that is the other part after applying. So this was all about nodes and element. Now we'll move ahead with the modeling using wizards. So basically we have got certain base structures. In structure type, in structures you go in base structures, in which you can create n number of beams, you can create n number of columns at certain location, you can create arches, you can create frames, also you can create trusses, you can create plate elements and shell elements as well. So let's see how it is done. So you can go to structure. In structure there is base structures, beams. So there are n number of beams you want to create. That can be done. Say I want, this is the distance that I give, I add, everything is displayed. Here the wizard has the option to do auto boundary condition, in which you can define what type of boundary conditions you would like to give. By default it has simply supported. You can assign your beam or column option over here. Then there is insert, at which location you would like to insert it, and say apply. So in this way your beams can be created. You can turn off the line grids that we had been created by turning the line turning over here the line grid. We can turn it off here. So now we don't see the line grids and it won't get snapped also. Next we'll go to the columns. So I want to create the 3 meter distance, say let's say 10 times, add. Over here the boundary conditions are two, they have given pin and fixed. I can select my material property, I can select my section property also. Then insert at which location. At here we can see which point they can take for inserting. Let's say I want to take this point. I can change the rotation angles. Now let me tell you that alpha is to change the angle about x axis, beta about y axis, and gamma about z axis. Also, as you must have noticed, let's apply first. Okay, so as you must have noticed that the xy plane is the horizontal axis, horizontal plane, and the z is the vertical direction. So now we can see over here that a column has been created. In the work stream menu, you can see that the boundary conditions have been defined by default. So you can remove this, indicates that it is a simply supported. This indicates that it is a fixed one. And the warping, the 0 indicates that the warping has been not considered, released. So we can delete them also. So now only one fixed condition has been remained. So all these options you can do in the workstream menu itself. Let's go ahead with the arch. So in arch you can create circular, ellipse, elliptical, parabolic, centenary, second order equation, third order equation. So all these types are available. Insert at certain location. So over here also we have given it the option to give the supports. So as you can see over here, an arch has been created, parabolic arch. Now in frames, you can give distance, say repeat. You can create an entire plan, a simple plan by using this option, or the entire plan in this option itself. Generate the frame. with the beta angle 90 degrees with material property and section property. And at the time of insertion, let's take one node. At the time of insertion, you can just, as you can see over here, the plane is vertical, XZ plane that they have shown. You want to rotate it about X axis. So alpha is X axis. You rotate it 90 degrees and say apply. So now you can see over here that the frame has been created, like the plan view has been created. So in this way you can also directly generate plan. Then truss. So there is a truss option in which different types are there available and different patterns are there. So you can have it symmetric or symmetric. You can have end verticals. You can give different section and material properties to the top, to the bottom, to the verticals, to the diagonals. So this can be done and you can insert it at the insertion point. So you can see over here that the truss has been generated. Similarly, you can do with the plates in which openings also will be available, rectangular or circular openings. And there is shells option in which you can have frustum of cones also, then entire global, or you can create domes as well with thickness given. So you can see over here how the dome has been created. So in this way, wizards make it easy for you to create a model. Now let us go ahead and see what all importing options we have. That is from AutoCAD, Revit, Tekla, Etabs, Planven, STAD. So if you have created already any plan in AutoCAD, maybe may it be 2D or 3D, so that can be done. So let me show you. So this is in AutoCAD, you can see over here. This is a 2D plan over here, and this is our 3D. So I've created different layers for both. I've created different layers for beams, for columns, and for plates as well. Now in this you need to take care about certain things. First of all, line or polyline in the DXF file that we have generated right now, they will be imported as beam elements, and open polylines will create multiple beam elements. Then if you want to create plate elements like I just showed right now for the slabs, a 3-noded or a 4-noded closed polyline can be done. And any closed polylines with more than 4 nodes will create multiple beams. It won't create a plate. Next is that the surface or 3D face in DXF file will be imported as plate element, and solids cannot be imported, and the curves or arcs that we have created in AutoCAD or in CAD files, they cannot be imported. You have to create multiple beams on a curve and that can be imported. Then unit system, you need to take care for the unit system. It should match with with Midas Gen and the CAD file. Then the grid lines that we have just seen, they also can be imported from AutoCAD using the dimension options. So this is the file that we will import in Midas Gen. So let's take a new. Okay, so now we have a new file. You can import from here the AutoCAD DXF file. So over here we have got different layers. First we'll do with the 2D model, the beams and slab that I had created. So I can have the option to just import the nodes, or I can import the entire node and element. Over here I can add the material properties. I do not have to like go again to the properties tab and do it. And the section properties. So the section properties also, I can have them just directly imported instead of creating. So after you install Midas Gen, in program files, you'll get certain tutorials. So these are some tutorials that I have, and I imported the properties from those tutorials over here. You can create your by default section. You can add thicknesses separately. Okay, so now I have created beams and slabs in AutoCAD. All I have to see is the unit, and I have to see that the unit that I had given for AutoCAD. You just have to click on apply, and now we can see over here that the entire frame has been, or the entire plan has been imported. Similarly, I can get the 3D model directly imported over here. So the entire 3D model has been imported in Midas Gen. This saves a lot of time, and you can directly start with giving your different, maybe you want to give different properties, or else there are groups that have been created using the layer option. So directly different groups have been created for different layers, and you can give your loads or any properties. So this was about importing in AutoCAD. Okay, let's go ahead. Next importing option is that you can also import from Revit structures. So any architect who has done the model using Revit, so that can be imported in Midas Gen. You can see over here all the functions and in what way the certain elements or certain functions, they can be put from Revit to Gen and Gen to Revit. So it's like you have to first create in Revit and then to Gen. So these are some important points that we need to understand while creating import file from while importing file from Revit. So you have to first export this analytical model that you have created in Revit to Midas Gen. An MGT file is generated. Then there is option to import the MGT file into Gen, and then you have to perform the analysis, do the design, and you can also do optimization. You can again export this updated Midas Gen file to MGT file and update the Revit model. So these are few options. You can watch at this link how to import from Revit structures, like the importing at the Revit structure point. So this is a structure from Revit which can be put into Gen. This is how it will look. So if any assigned section is changed to other predefined section in the model, the corresponding member in Revit will be updated accordingly. And if assigned section is changed to other newly added section in Midas Gen, the corresponding member in Revit will be assigned to a default section. Now this same section, if it is modified, if an element is modified, the family and type of the element, it will not be recognized by Midas Gen. And this means that any section that may become necessary should be preloaded into the Revit project before sending the model to Midas Gen. And this will help their family or the type can be specified during the updating of the model. Otherwise, the default will be the one that is given by Midas Gen. And if material data is assigned, uh, that is assigned in Midas Gen, it is modified, then a default material will be assigned, a different default material will be assigned in Revit. Now before sending any model from Revit to Midas Gen, you need to check that you have to make some adjustments to analytical model and ensure the consistency of it. Then even though nodes and elements can be deleted, you should not renumber them in Midas Gen, because the update mechanism is it is identified by the numeric IDs. Let's go ahead about the Tekla structures. Now even Tekla structures can be imported into Midas Gen. So down there you can see there is a link to watch how Tekla structures, or what all you have to do in Tekla to get it into Midas Gen. Okay, moving ahead. Now we'll see how Etabs model can be imported from Etabs to Midas Gen. So first of all, they can be used by using SAP files, or they can be converted into MGT files using a converter. Then the section stiffness and the scale factors, they won't be imported. And you need to check that the wind and seismic loads are again defined in Midas Gen, because they are not imported. So let's see the file converter. So this is a file converter. So you can get it by asking or sending us an email. So you can convert PlanWin files, that is BLW files, to MGT files. This is again with slab or without slab you can do. You can also do MDB to MGT, that is MDB is a Etab file to Midas Gen file. Also a Midas Gen file can be converted to Etabs file using this converter. So let's take one example. An MDB file has been converted. So you can see that it has not read the beam and the column designs. Let's go to Midas Gen. Make a new one. Okay, so now we'll import it using Midas Gen MGT file. So a file over there itself will be generated, MGT file. So let us open it. So if there are errors, you can always go in the tools where there is MGT command shell. You can open the file over here. So if you run, you can over here there will be option, there will be warnings or errors given. So you can just all you have to do is go to that line. So this option happens because certain lines are not understood by Midas Gen, which are not necessary. Run it again. Again line 246 has an error. Okay. Now there are no warnings, one error. So line 12 has an error. Lastly, line 214. Okay. So finally, by doing these, we can see that the model has been brought from Etabs to Midas Gen. So over here in work tree menu, we can understand what all things have been input. So as you can see over here, these lines for columns that have been generated, they have been given an undefined column. So let us change over here itself our column. Okay, and the property will be assigned automatically to all of them. So in this way, you can import the EDB files to Gen files. Similarly, you can do this by using the converter, the BLW files to MGT, and use these MGT files, or you can use the MGT command shell to understand where the errors or where the warnings are coming from or change it accordingly. Okay. Then moving ahead, we can also import from STAD. So in this, if member shell or solid, if they have the same ID, then warning messages will be printed out, and the program, it reassigns the IDs and then it will import. Then only AISC database sections can be imported. Then floor loads that are defined with XY range, they will not be converted. And wind and seismic loads are not converted. So let us see what happens when you import a stat file. Let's take a new. Okay, so now we can import a stat file. Okay, so this will be save and convert. So all these warnings are because of the same reason, and entire model has been generated from stat. Okay, so this way we can import from stat models. So that was all about how to do modeling by using node elements or by using wizards or by importing the model from AutoCAD, from Revit, Tekla, Etabs and Stat. So basically speaking, that assigning the loads and doing the design is very easily done using Midas Gen. If you have seen more tutorials or you have visited before webinars, at that in that you can view the assigning of loads and the designing or the analysis. It is very much easy. Now let's go ahead with an introduction to Midas D Shop. So after you have done designing, you can do your D Shop. So let me show first of all a D Shop, a file that is generated. It has been designed for beams, for the columns as well as for the shear walls. Okay, so now all I have to do is export it to Midas drawing file and save it. So file conversion has been completed. Now we'll go to Midas D Shop. Uh, this will take a little bit of time. My system is a little slow right now. Just So we have opened right now Midas D shop. So let's take a new file. Then you have to import Midas Gen, the one that we had created before. So your entire model has been created over here. So we can define our design code over here for column bar, steel and SRC. Okay, then after this you can view your plans, different plans, and if you have designed the columns then you can view that over here, and the beams by just double clicking. So if you just design all the beams, then design of columns, and design of wall also, then you export it to Midas drawing file. Let us replace it. Let's take a new model and do the same importing. Okay, now here we can see different floor plans. If you double click on any of the beams, you can view the design that has been done, or the columns, and you can make any changes over here itself. Also for the walls, after this all you have to do is grouping of members. You can do it by auto grouping or you can do it manually. For columns, for walls also. Then there are other different options where you can have general notes that you want to apply, or you want to change eccentricity of the columns or the beams, change of steel connections if it's a steel structure. Then you can have over here the drawing settings, that is for plan in which way you want it, the beams, the columns or the walls. Then the section style for the beam, columns, bracings, walls or footings also. Then there are other options for drafting. We have got output option over here. So here we have these section properties which if required you can turn them on or you can turn them off. So all these plans are created. Now the output that is there, we can get it in AutoCAD or we can get it in Midas CAD also. So let us see in how in AutoCAD we can get all these draftings done. So all you have to do is right now just double click on the auto drawing. Basically over here you need to see where you have put your drawings. So I have put it at the right location over here, is in the D shop folder. All you have to do right now is say auto generate. double click on generate auto drawings. And the drawings have been generated. Now let us go in the same folder. So over here all the files have been created, the column sections. So you can see that the dimensions have been given, the size, the main rebars, the ties. So all these things for columns we can view. Similarly, we can get longitudinal as well as cross sections for beams. So it makes it easier for the people to understand, the site engineers to understand. Also, we can have all the plans ready with us. Okay, so similarly, we can create different drawings for wall rebars or for columns for beams. So this is what we have seen. We can create plans, beams, columns, and shear walls in AutoCAD as well as in Midas CAD. Also, lastly, I would like to tell that it is very easy for doing report generation in Midas Gen. And lastly, we'll start with the question answer session. So you can write at the questions dialog box. Okay, let's start from the first. You can change the modulus of elasticity in the properties itself. So yeah, material properties. So you can modify the section. You can say none, and this is how you can change the modulus of elasticity. Then we have another question. When assigning floor loads, how does the option convert to beam load type make difference? So in this case, the loading option that you're talking about, so if you do not want any floor loads, so you want them to be seen as element loads, then that option can be useful. It is dependent on how you want it to be seen or how do you want it to be added to the elements. Next, the loads are different from what Midas Gen takes and what the other softwares take. That's why certain loads are not imported, like wind loads or seismic loads. So there is a very good way to assign all those loads in Midas Gen. The eccentricity of columns, they can be changed in the assigning of properties itself. So you modify over here, offsets can be given. So over here you can change the offsets. Okay, so the rest of the questions will be mailing to you, sending you emails with all the questions. And we'll also be sending you this video of this webinar session that has been held. Also, there are some handouts that have been given, the comparison between the other softwares and Midas, and also the catalog. That you can get it downloaded. You can download it right now. Okay. Now we'll end this session. If any queries, you can send us on techsupport@midasit.com. Thank you for attending our session.